In this video, the learner will determine the midpoint of a line segment in 2 dimensions. First, what is a midpoint? A midpoint is a point that bisects a segment. That word bisect means to cut into 2 equal parts. So this point M, if M is the midpoint of segment AB, then M is between A and B, and the measure of AM is equal to the measure of MB. So notice that point M cuts that segment into 2 equal parts. Now let's look at how to calculate the midpoint in 1 dimension. 1 dimension means just on the number line, how we would find the midpoint of segment AB, where A is at -9, B is at +5. Well, first we could use a counting strategy where we could just count the entire distance, which would be 14. We know the midpoint needs to be halfway along that segment, so half of 14 is 7. We can count that 7 units from A and end on -2, and we know our midpoint then is at -2. Because the midpoint is exactly halfway, we could have counted those 7 units from point B instead, and we still would have ended on that midpoint of -2. We can also find the midpoint algebraically using a formula. We know that the midpoint is going to be halfway between A and B. So we can take the coordinates of those points, add them up, and average them to find the middle. So take the 2 x values for the coordinates, -9 and +5, add them together, and divide by 2. We get -4 over 2, which is our midpoint at -2. In 2 dimensions, we're looking at the xy coordinate plane. We want to find the midpoint of this segment AB. Graphically, we can count the vertical and horizontal distances and then take half of those. So the vertical and horizontal distances here are 4 and 8. I know that the midpoint is half of that distance. So half of 4 is 2. Half of 8 is 4. So notice we can count 1, 2, 1, 2, 3, 4. We could have also counted that from our other endpoint. We have the 1, 2, 1, 2, 3, 4. That horizontal distance of 4 and vertical distance of 2 gives us our midpoint here at +2, +3. Now we could have also used the formula for midpoint. We're taking the average of the x's and the average of the y's to find the middle of each value, which is what we did graphically, and now we're going to do it algebraically. So we'll take the x coordinates of the 2 points, add them together and divide by 2. Take the y coordinates of those and add them up and divide by 2. So -2 plus 6 divided by 2 and 1 plus 5 divided by 2 gives us +4 over 2 and 6 over 2, which reduces to 2, 3, which is where we counted to that midpoint. I want you to try these on your own. Go ahead and find the midpoint in each problem. Now for another problem. This time we're given T is the midpoint of RS. So we're given the point T and the point R, and we want to locate the other end point. R is located at +8, 7, and T is located at 5, 1. We're going to find the location of the other end point. To do this graphically, of course you would want to first plot the points that you know. We know that T is the midpoint of our segment. So we know S has to be down here somewhere. We also know that the distance from R to T is the same as T to S because that midpoint bisects the segment. So I could count those vertical and horizontal distances of 6 and 3 and then double that. So then from T count 6 and 3 again to end our point S at 2, -5. For the formula, we're going to use our midpoint formula, but in a different way because we're given different information. Here, that x-coordinate for the midpoint is given by x2 plus x1 divided by 2. The y-coordinate of the midpoint is given by y2 plus y1 divided by 2. These x and y values were already given to us with that point t at 5, positive 1. We can use those values and work backwards algebraically. So I'm going to use the x part of the formula to find the x value of s. I know the x value of my midpoint is 5, and I know one of the x values of the endpoint that I have is 8. So plug those values in, and I can solve algebraically for that other x value. So I would multiply by 2 on both sides and get 8 plus x sub 1 is equal to 10. Subtract 8 from both sides, and so our missing x value is positive 2, which is what we can see graphically. For the y value, I'm going to use the y part of the formula with the y coordinate from the midpoint. So the y coordinate from the midpoint was 1, and the y coordinate from the end point that we know is 7. Now algebraically solve for the other y value. Multiply by 2 on both sides to get 2 equals y2 plus 7, and subtract 7. I now know the y value of my point that I'm missing is negative 5. And that's what we found graphically is 2, negative 5. So point S's coordinates are 2, negative 5. These are two problems I want you to try on your own. You're given the midpoint and one end point, and I want you to find the other end point. In this last example, it's an algebraic example. What is the measure of segment PR if Q is the midpoint of segment PR? We're given expressions that represent QR and PR. Since we know that Q is the midpoint, we know that PQ and QR have to be congruent to one another. Therefore, their measures have to be equal. So it's going to take 2 of these expressions, 6 minus 3x, to equal 14x minus 2. So by the definition of midpoint, I know 2 times this segment is going to equal the whole segment. From here, we just work the algebraic equation. So first I'm going to distribute, then add 6x to both sides, subtract 2 from both sides, and then divide by 20. So we have 10 divided by 20, which gives us 1/2. Now, it asks to find the measure of PR. So we would have to plug 1/2 in to x. So 1/2 of 14 is 7, plus 2 is 9. So the measure of PR is 9. I want you to answer this question in your notes. What would be another way that you could set up this equation but still get the same answer?